Hello. Today we are going to be demonstrating how to build a simple start-stop motor control circuit program in RSLogix 500. Now, this is a pretty simple circuit. It's something you'll see a lot, and it's a really great way to get yourself familiar with the program itself. So I'm going to start off with a few of the basic concepts of ladder logic, and then I'll show you a few of the devices that we're going to be using today, and then we'll go ahead and build the circuit. So ladder logic is sort of like visual electrical programming. You have different conditions and different executions that you can do, and you can put those together and basically make what is sort of a program. It can get a lot more complicated than that, but that's a pretty simple explanation, and that's what I'm going to go ahead and start with. So our first symbol is the contact. Now, the contact, whether it's open or closed, as energy travels from left to right, will decide whether or not to let it through. This is kind of like an if statement in programming. There are two types of contacts. The first one I'm showing you here is normally open. That means that in its resting state, it's open and doesn't let energy through, and when its respective coil gets energized, it closes. The opposite is true for a normally closed contact. In its resting state, it's closed and it lets electricity through, and when its coil gets energized, the contact opens up. The third part of our equation is the coil. Now, a coil usually represents actual physical electrical output on the PLC itself. However, like I was saying, they can also be connected to a contact in the actual PLC program. This is where it starts to get tricky. So now that everyone's up to speed, let's go ahead and do the actual programming. So we've got RSLogix open here, and we have a new program started that's totally blank, just the end statement. Now the first thing we're going to do is add a new rung. Let's see if I can get that down there. Because you always want that end statement to be down there by itself. Then we're going to add a little sub-rung to the rung we just created. We're going to take two normally open contacts, put them on top of each other, and then a normally closed contact after that, and a coil. That's going to be the motor down at the far end. So now that we've got the basic program down, like I said, it is very simple. The next step is assigning those different contacts and relays different numbers. Now, normally what you would do is you would give the contacts input numbers, which is right here, and those inputs are actually related to physical buttons on the PLC itself. And the coil would actually be related to an output, so that when the coil gets energized, the PLC actually sends out real electricity to a real motor. Now, because I don't have a PLC hooked up right now, and we're just doing this for a test, everything's going to be on binary, which is just kind of an arbitrary number in your computer. The idea behind this program is that you have a stop button, start button, and a coil, which is the motor. So what happens is you tap the start button, and that closes the contact, lets energy all the way through to the coil. Now this is where it gets fun. The coil, when it gets energized, also energizes this contact, which is connected to the coil. So what happens is the coil gets energized, this contact closes, that you can then release the start button, open it back up, and the energy will travel down through here, through that closed contact that's connected to the coil, go back here, and back through the coil. So now the coil is stuck on even though you've let go of the start button. Then you can just press the stop button, open this up, cut off energy, and turn everything back off. It's simple but eloquent. And alright, click on element here, that's B30. So click on properties, and under elements, type in 3. So now we have B30, 1, and 2. So let's put B30, click and drag it to the start button, B31 on the stop button, and B32 on the coil, but also on the coil's contact, because like I said, we want those to turn on and off at the same time. And there you have it. Go ahead and test out your program and pat yourself on the back, because you just finished your first ladder logic program. Thanks for watching.